Hello, welcome to the Matt Healy Interactive Physics Learning Studio. We are going to do the Newton Extra, U-Texas. I know you think U-Texases are hard, but we can make them easy, one problem at a time. Today I will be working on questions 1 through 4 on the Newton Extra U-Texas for AP Physics. You get 4 questions for the price of 1. This is a great value. Also, call now at 1-800-MATT-HEALY and you will get 7 more questions free, okay? Toll-free number, call now. But wait, call in the next 30 seconds and you will receive a free booklight to go along with your order so you can use that booklight to work on physics in the dark. Starting the questions.
Why did mine play?
Starting the questions now. We're going to start with number 1.
You don't have to talk so loud.
Okay? So, can you please stop? Number 1.
Can you please stop?
Sorry, my colleagues are distracting me. Number 1, it has a pulley drawn for the picture. So I'm going to draw the pulley first, and then I'm going to give you the problem. So I've already taken up enough of your time, so let me just draw this right quick. Alright, if that wasn't the quickest drawing of a pulley that you've ever seen, then you need to reevaluate your life. Alright?
Did you figure out how to do that?
Anyway, can you guys be quiet? Yep. What's that?
Sorry.
He said he wants a raise? Okay, we can give it to him. Alright, yeah, it's just one of my employees. Anyway, we got this pulley here, and this pulley is going to be what we're going to use for questions 1 through 4, so get used to it, get yourself acclimated with the pulley system here, right? So you see MA, you know, it's pulling down. No, MA is at the bottom, but MB is about to pull it down. It's a moving pulley, okay? Like you pull on MB, MA comes up, okay? I hope I'm making this simple enough. If not, you can contact me via Twitter @_MattHealy and ask me any questions about physics, okay? Get my follow game up. Instagram, MattHealy5, you know. Vine, check me out on Vine, Matt Healy. My Vine's pretty fresh. Okay, so, anyway. So, for number 1, okay, well, here's the actual, this is just the given for number 1, for 1 through 4. Consider a massless, so there's no mass, frictionless pulley. The pulley is it's negligible, okay, attached to a ceiling. A massless, inextensible string is attached to the masses MB and MA, where MB is greater than MA. So that right there, the MB greater than MA, that tells you that MB is the one pulling down on MA, okay? So the tensions, TX, TZ, TY, that's what T stands for, tension, and the gravitational constant G are magnitudes, okay? So number 1 says, what is true about tensions TX and TY? Okay? And so for each one, the tension has to be less than the weight that is pulling it down, or the tension is pulling it up. It's less than, okay? So you would look at this, and knowing that fact, you would know that TX is less than MB times G. You have to add gravity into it. The tension is less than the mass times the gravity. Okay? It's just physics, alright? So, TX is less than MBG. And then TY on this side, you know, TY right here, that is going to be less. Okay. Can I restate what I just said? Alright. So, on the left side, because MB is greater than MA, MB is pulling the pulley down. So that means that it's greater than the tension, because the tension isn't holding it up, obviously. It's pulling it down. So that's why MBG is greater than TX. But on the other side, it's actually opposite. Okay? TY is greater than MA because MA is getting pulled up, because the right side is getting pulled up because the left side is going down. Again, because MB weighs more than MA. That's given. Okay? So that means the tension of Ty is greater than ma times gravity because it's pulling it up, okay? Sorry about the confusion. We're going to move on to number 2 now, okay? What is the relationship between Tx and Ty? Well, I hate to break it to you, but they're equivalent, okay? Just look at the facts in front of you, okay? I hope this actually didn't give me trouble at all, so you should know this, okay? Tx equals Ty because they're equal, they're symmetrical, okay? The weights, it doesn't matter. It doesn't affect, the tension will always be the same. They are the same, okay? Tx equals Ty, that's simple. Number 3, which relationship about Tz is true? Well, let's take a look at Tz right here, okay? Let's take a look. Here's Tz. What is the relationship that's true? And it's in accordance to the mb times gravity plus the ma times gravity. Well, this is the tension up here, holding it together, okay? This right here, it's holding the whole pulley up, okay? But underneath, this is moving down here, okay? And we know that when it moves down, which we saw mb do, it's moving down, that means it's greater than its tension, Tx. So if you look at it in the bigger scale, mb plus ma is greater than Tz. Okay? So mbg plus mag is greater than Tz. What is the relationship between the 3 tensions? Okay, now that is just, that's a mind-blowing thing in its own. Okay, you know that Tx is equal to Ty. However, how is it according to Tz? Well, since Tz is up here, you know, hold on. Since Tz is up here holding this together, all of it, these 2 tensions, these 2 are symmetrical, so they're even, but these 2 are equal to Tz. So Tx plus Ty equals Tz. And that is number 4. I hope you got a lot out of this video. Sorry for the misconfusion at the beginning. I hope to see you guys next time. Please recommend me. Shout me out. Tell Mr. Spudik it was a great video. Have a nice day. Good luck in the future.